Over the last several decades, there has been a credibility revolution in empirical economics. This is because credibility is most important. But here's the paradox. No matter how sophisticated our methods, credibility ultimately rests on untestable assumptions. Today, we'll see how balance checks and model fit are really the same activity, building confidence in assumptions we can never fully prove. Every empirical economist faces the same challenge, convincing yourself and a skeptical audience that the results you've found are real and not an artifact of your methodology. But the types of evidence used to persuade yourself and others of the validity of your approach differ based on the method that you're using. For less structural, experimental-based approaches, typically we would validate the design. For structural approaches, we validate the model. This is primarily because we want to validate the main source of identification for our parameters. These might seem like two completely different activities, but they're really two different ways of answering the same question. Are there alternative explanations for what I'm seeing? In less structural, experimental approaches, we validate the research design, which is colloquially called the identification strategy. And we can do this in different ways depending on which specific type of experimental method we're using. If we're doing a true randomized experiment, then a balance check would be the first stop for validation. The balance check compares the treatment and control groups on all the observables we can see about them, and randomization, on average, would give us minimal and insignificant differences between the two groups on everything except the treatment and the outcome. The limitation of a balance check is that we can't assess the balance on unobservables, which is what we really care about. In difference in differences estimation, we do something similar. We look at whether the treatment and control groups were trending in parallel ways before treatment was given. But the key assumption here that's untestable is that the trends remain parallel after treatment. By definition, we can't see this, and so ultimately we can't test that assumption. However, parallel pre-trends do provide some evidence in the same way that a balance check on observables provides some evidence. There are also placebo tests that we could employ. Placebo tests are basically there to interrogate whether we see any effects when we know we shouldn't see any. We could do this by testing on time periods before treatment. We could test on outcomes that shouldn't be affected. In general, placebo tests are tools for assessing the plausibility of our research design and its assumptions relative to departures from those assumptions. The logic is sound. If these tests pass, then our identification strategy has merit. If they fail, then something is wrong with the identification strategy. However, ultimately these assumptions are untestable because they rely on things that we cannot observe. By contrast, more structural work uses the model for identification, and so validation is geared towards the model. And here, what is untestable is the specification of the model. One thing we can use to assess whether the model is correctly specified is whether the estimated parameter values make sense. We can also use the model to generate data, and then we can compare the generated data with the actual data that we gave the model and see if the data matches on average or at different parts of the distribution. Typically, we would focus on the moments that we used in estimation when doing this comparison, but we could also focus on moments of the data that we didn't use in estimation. And the latter we would call the model fit on the untargeted moments. Finally, we can do out-of-sample predictions where we can use the model in an entirely new context to generate data and see if it matches the data from that actual context. That would be the highest bar for validity of a structural model. Typically, untargeted moments being a good fit is a high enough bar for credibility of a structural model. And the reason for that is that anyone can come up with a model that fits the data that it was estimated on, but we want to see whether the model can generate things that it didn't see. So if you're familiar with machine learning, this is the notion of overfitting. So if a model is overfit, then it matches the estimation sample perfectly, but it fails to generalize, and in fact generalizes very poorly. So that's the same idea behind wanting to assess model fit on untargeted moments. But the deeper question that both approaches, both experimental and more structural approaches, are trying to answer is the following. Given what I observe about the world, are my conclusions correct? Are they credible? In an experiment, if the research design is credible or valid, then we can conclude that X causes Y. In a more structural approach, if the model fit checks pass, then we can conclude that the mechanisms in the model actually describe the world that we live in. Both of these approaches require leaps of faith because in randomized experiments, we're assuming that the design is going to give us evidence that actually relates to the real world policy that we might be evaluating. And more structural methods are going to assume that the mechanisms that are encoded or included in the structural model are actually representative of the real world mechanisms through which treatment is operating. And these validation tests are going to help us assess how close we are to these goals. In closing, there's a paradox in all empirical work, and that's that even though we might employ sophisticated methods, our credibility ultimately rests on assumptions that we cannot fully test. Randomization guarantees balance in expectation, but we can never know for the given sample that we've looked at whether it actually is true. And parallel trends, by definition, can't be tested in the actual periods when we want them to have held. And on the structural side, any model can be overfit to produce a good fit of the data. So just remember that whether you're doing balance checks or model fit validation, you're not actually providing evidence of your maintained assumptions, but you are building confidence in them. The credibility revolution didn't solve this problem, but it did make us more honest about it.